Today, we're answering the question, where does glucose come from? And of course, the answer to that is glucose comes from photosynthesis. Photosynthesis is the process plants use, taking carbon dioxide for mass, for the actual chemicals that become the glucose, water for electrons and protons, and sunlight to excite electrons to build glucose. With what as a byproduct? What's the chemical that comes out of photosynthesis that plants don't use for photosynthesis? Yeah, oxygen. So there is no getting around it. We are going to have to balance a chemical equation. Do you remember that? You remember how to do it? How many of you had a hard time with that last year, balancing chemical equations? Okay, well, the good news is you're smarter now. It's not going to be hard, I promise. Yes, you are, Hazen. Here's the equation. Remember, a chemical equation is just showing what the reactants, the things that react to make the chemical reaction happen, and the products are. And the reactants are over here on the left. That's carbon dioxide and water. And the products are glucose. That's C6H12O6, if you didn't know, and oxygen. So why do we balance equations? Well, because we know that this can't be right. We know this can't be right because carbon dioxide only has one carbon and two oxygens, and somehow we've gotten from that to C6H12O6. Well, you can't just create new atoms of an element, right? They had to come from somewhere. So we know it's not just one carbon dioxide and one water that makes a glucose and an oxygen. It must be more. So in balancing an equation, what we do is we put an imaginary blank to the left of every molecule, because that's what these are. O2 is a molecule of gaseous oxygen. This is a molecule of glucose, molecule of water, molecule of carbon dioxide. You put a blank to the left, and you're allowed to put a full-size number in any of those blanks to say how many molecules of that there are. And the goal is to put the right numbers in the blanks to get equal numbers of carbon atoms here and here, to get equal numbers of oxygen here and here, and to get equal hydrogen here and here. Does that make sense? Any number you put, for example, if I were to put a 10 here, affects every number in that one molecule. So that would make how many of these? How many of these? 120 and 60 of these. So just know that if you put a number somewhere, it affects each element in that molecule only. Ready? Figure out how to balance that equation. I'll give you a big hint, and that big hint is leave oxygen for last. Oxygen's the scary one, right? It's in every term in there. Do the ones that are all by themselves first. Go. Raise your hand if you got it. Yeah? Okay. What'd you start with, carbon or hydrogen? Okay, start with carbon. How do we balance carbon? Riley? No, do carbon first.
So the carbon, you would just put 3
in front of?
No, that one here.
So that makes 3 carbons here, 6 carbons here.
Oh, wait, sorry. Then it would be 6.
6 in that same spot?
Yeah.
I need a better marker. 6. Okay, so now we have 6 carbons on this side, 6 carbons on this side. Well done. Next. I said do oxygen last. So let's deal with hydrogen. 6 what? Where does the 6 go? There's two places, there's hydrogen here, and there's hydrogen here. That's water. Okay, in front of the water?
Yeah.
You want a 6. Good. So 6 times 2 means 12 hydrogen here and 12 hydrogen here. Perfect. Okay, so carbon and hydrogen are balanced. Now we have to deal with oxygen. That would be a super pain in the butt, except we have oxygen all by itself on the right. We have this, which is a huge bonus because now, okay, how many oxygens are there on the left? Right now? There's 6's in front of both of those terms. Multiply out. How many oxygens are there on the left of the equation? 18. How do you get 18? Well, 6 times 2 is 12. 6 times 1. If there's no number, it's a 1, right? So that's 12 plus 6 is 18. So there are 18 oxygens on this side. We need there to be 18 on this side. How many are there right now? There's 8, but we can think of it as 6 plus 2. And we want 6 plus something that will make 18. What's a something that will make 18 when added to 6? So we want this to be 12, right? And how do we do that? So this is easy to remember, isn't it? Especially if you're a metalhead. 6, 6, 6. Balanced. And what does that tell us? That tells us that it takes 6 carbon dioxides and 6 waters to make just 1 glucose. So we'll need 6 CO2s. The plant will need 6 CO2s for every 1 glucose it's going to make. Does that make sense? Cool. You're still smarter than a Harvard graduate, right? Yeah, because you know, unlike they did, you know that it's carbon, and it's the carbon dioxide from thin air that plants use to make their stuff. Starting with glucose, but then they build all kinds of molecules. So what this requires, the kind of magic ingredient here, is chlorophyll. And the special thing about chlorophyll is the way it holds electrons. Those little buzzy things on the outside of atoms, they can have different energy levels. Well, chlorophyll holds its electrons such that when sunlight hits it, its electrons get raise your hand if you have a younger sibling. Raise your hand if sometimes that younger sibling has a tendency to get over excited, hyper active. And raise your hand if there's a trigger. What's the trigger?
Usually, like, if he gets something he wants, or like if he eats something that gives him a lot of energy.
If he gets some, isn't it ironic? You give them what they want and it just makes them more hyper. Oh my gosh, it's the worst.
My sister, whenever my parents disagree with me, she kind of gets a little bit frazzled.
That sounds like my daughter. Yeah. Fine then.
Okay.
Okay. Other triggers? I'm doing it anyway. Yeah, you can't. What are you going to do about it? So I want you to imagine that younger sibling of yours in a full-on, like near epileptic, like vibrating, like pinball machine kind of hyperactive fit. That's chlorophyll's electron when sunlight hits it. And now I want you to imagine that you have this black belt of a babysitter that you can call that can come in the middle of a hyperactive fit by your younger sibling, grab that kid by the scruff of the neck, and drop her into a treadmill, a magic treadmill that will power your house for a week. That is the equivalent of what a plant is doing when it does photosynthesis. It's taking the excited electrons from chlorophyll and dropping them into a magic treadmill, a set of reactions that are able to power the production of glucose. That's what's going on. There's two sets of reactions going on in photosynthesis. We won't go into really any detail beyond this because, 2020. But there are reactions in photosynthesis that do require light. That's the ones where chlorophyll's doing its thing, exciting its electrons. Then there's the light-independent reactions that don't require sunlight. That's where the little hyperactive electron is being brought to. It gets excited in the light-dependent reactions, and then it gets dropped off at the light-independent reactions to do. Questions? Tomorrow, we will answer the second question, which is, how does everybody actually get ATP out of their glucose? We said ATP is kind of the big deal. It's the energy molecule, the cash that you can spend. Well, plants build glucose for everybody to have, but everybody, including plants, have to use that glucose to make ATP. I am going to give you homework. This is the chapter 9 you guys are reading. We are skimming like crazy through both of these chapters. So those guided readings are going to need to be done. Beyond that, there's not going to be a lot. So please put some effort into these.